Okay, here's our first notes on antiderivatives, also known as integration. So these are the same thing, integration and antiderivatives. We're talking about the same thing. So notation. So when we've been talking about antiderivative, if I give you f of x, the antiderivative is capital F of x. In integral notation, if the function is f of x, the integral is looks like this. So therefore, finding the antiderivative and the derivative is the same thing. So the way that this question could be written is find f of x when f of x equals x squared. Another way of writing that is find the integral of x squared dx. And I'm going to talk about what dx means. So this is the normal way of writing it. It's very seldom that you're going to actually see integration written like this. So this is kind of an introductory baby step kind of way of doing it, but the way that you're going to see it is like this. Next week, on Monday, we're going to talk about what does this symbol mean. It means, like I tell you right here, it means that this is a sum, but a sum of what? What are we adding together? So we're going to see that on Monday. But right now, we just want to get used to the different basic rules of integration. So if we know the first derivative, how do we go backwards to find the original function? So the dx, let's talk about what the dx means. So notice over here in my function, in my f of x, I have an x and I have an n. And so the dx is here to tell us which letter is the variable. So the x is the variable. N is just some number that we don't know yet. But x is, you know, like when you're plotting a line, you can put in any number for x and then figure out what the corresponding y is. Okay, so x is a variable. That's the variable part of the equation. N is a number, but we just don't know what it is when we're writing the formula. But when we do have an actual problem, that would actually be a number. So the dx is telling us which letter is the variable. The x is the variable. Okay, so in this one, notice I have 3 letters. So which one is the variable? The variable, this tells me which one is the variable. So the variable is t. So we're going to take the derivative in with respect to t. So a is going to be a number, n is going to be a number. So for example, like 3t to the 5th power. Okay, these are going to change to numbers. The t is still going to be a letter. It's still your variable. Okay, so in a textbook, the way that a textbook would say this is they would say integrate with respect to x. So here, what this is telling us is that we are going to integrate with respect to x. Because it's possible to have a lot of letters in the problem, but you need to know which one is the variable, which one are we going to be worried about and using our rules of integration on. So this is integrate with respect to x. This one, since it says dt, it means that we're going to integrate with respect to t. Okay, so if this was written out in words, we would want to integrate this function with respect to t. That would be it, written out in words. So integrate with respect to t. So it's telling you which is the variable. All right, let's go ahead and look at our examples that we're going to do. So in class today, we actually practiced with all of these different types of situations, but we're going to go ahead and put some examples into our notes so that if you ever forget what's going on here, you can look at the examples in your notes. So here's the formula. I want to integrate k dx. So notice it's asking me with respect to x, but there's no x here. Okay, this k is a number. This is some number. It's a constant. Okay, this is our constant. It's some number. We just don't know what it is yet because this is a formula, but it could be a number. For example, I could ask to integrate 3 dx. So notice now my k is 3. So this is some number. This is a number. And we're going to integrate with respect to x. But notice there is no x. Okay? Notice there is no x, but I'm going to integrate with respect to x. Okay, there is no x, so how can I write that with an x if there's no x? So we would write x to the power of 0 is another way of writing that. So this is the same thing as writing 3 times x to the power of 0, and I'm integrating with respect to x. So now we can just use our basic rule, which I have down here. Our basic rule says that we're going to add 1 to the exponent, so 0 plus 1 is 1. And then we're going to multiply, we're going to multiply that by 1 over that same exponent. Okay, so when we end up doing this, we get x to the first power, and then we do 1 times 3 is 3. So notice what happened. If I have the integral of 3 dx, my answer is just 3x. Okay, so notice down here in the next formula, this is the way that you generally see the formula written in textbooks. The way that we wrote it in class today is we wrote it 1 over n plus 1 times x to the n plus 1. Okay, so this is how we wrote it in class today, but this is how you would see it written usually in a textbook. They put the n plus 1 on the bottom of the x part of the function. Okay, so if we do an example, if we have x to the 15th dx, so I'm integrating with respect to x, I'm just going to use my little formula here. I'm going to have x to the n plus 1, so my n is 15, so I'm going to have x to the 15 plus 1 divided by n again is 15, plus 1. Oh, gosh, I almost forgot. I forgot to put the c on up here. Eek. Let me go back up there. Plus c. Man, so easy to forget. So make sure you double check your work. Okay, so, sorry, back to this one. So x to the n plus 1 over n plus 1, and then don't forget plus c. So we talked about this in class today. When we have the first derivative and we want to go backwards to the original function, any numbers, any plain numbers, any constants in the original function, when you take the derivative, they just disappear. So we don't know what it is. So we always have to write plus c to indicate that there could be some number over here. We just don't know what it is. Okay, so now we can go ahead and simplify this. So x to the 16th over 16 plus c. The way we've been writing it in class, though, we've been doing it like this, 1 over 16 x to the 16th plus c. So either way is fine. You can write it like that, or you can write it like, oops, sorry, I'm off the bottom. Or you can write it with 1/16 next to it. So this is how we were writing it in class today. That's kind of what we discovered, what you discovered on your own from doing the guessing and checking on the homework. But this is also a fair way of writing it, so either way is fine. Okay, the next situation is exactly like the previous one, except now we've got some number, and again, some constant that's being multiplied with our x exponential part. So what we notice in class today is that when you take the derivative of a function, if you are multiplying that function by a number, that number never disappears. You just keep carrying it from derivative to the next derivative to the next derivative. So we're going to go ahead and do an example of the situation right here. So I'm going to start with this one again, but this time I'm going to put in that 3. I'm going to write 3x to the 15th dx. So this is the same thing as doing 3 times x to the 15th dx. So if I just have a number in here being multiplied with my x, I can just pull it out to the side. Now I'm going to go ahead and integrate that x to the 15th. So I keep my 3, and then I'm going to integrate this. X to the 15, so x to the 15 plus 1 divided by 15 plus 1. And then because I don't know what the vertical translation was, I have to write my plus c, and then we can simplify this. I have 3 times x to the 16, all divided by 16. Or, if you prefer, you can keep the 3 and the 16 separate. You could write 3 over 16, x to the 16th, plus c. And there it is. Okay? So this would be acceptable. Sorry, I forgot to put the plus c there. Or this, plus 3. So let me move this over a little bit. keep forgetting to put the plus c. So equals 3x to the 16th over 16 plus c, or I can write it with a fraction separate, like that. All right. Okay, next thing is, what if I have two functions being added together? Well, you're just going to integrate them separately from each other. So, what is the example I wanted to do? Here it is. So, if I have the problem 2x squared plus 4x minus 1 dx, I can separate this out into three separate problems. This is the same as taking the integral of 2x squared dx, because I'm going to be taking the integral in respect to x, plus the integral of 4x dx minus the integral of 1 dx. Okay, so notice I've got those constants there in front. So again, I can move those out to the side. So I can write this as 2 times the integral of x squared dx plus 4 times the integral of x dx minus 1 times the integral of dx. Okay, this one you might not want to move out because that might be kind of confusing, but this is like the first one that I did. See how there's no x? That means you just put an x in there because it's like x to the 0. So it's like this situation over here where I had 3 dx. I could have pulled the 3 out to the side, or I can just slap an x next to the 3. Okay, so that's what's going on this third integral. Okay, so now if I integrate these, take the antiderivative, I'm going to keep my 2, and then I'm going to have x to the 2 plus 1, all of that divided by 2 plus 1. The next one is going to be 4 times x, that's x to the first, right? The invisible exponent is a 1, so this is going to be x to the 1 plus 1 over 1 plus 1 minus 1x. Now we can simplify this, so I end up with 2x to the third over 3, or I could have written it 2/3 times x cubed, either way it's fine, plus 4x squared over 1 plus 1 is 2. Oh, that one can be simplified. Minus 1x plus c. Okay, so I should have left myself more space. Sorry about that. I can simplify that one to just 2 over 1, or just 2. Okay, so I'm going to go ahead and now that I've done it, I'm going to just erase it and write it as 2x squared. Okay, so sorry about that. Hopefully you write smaller than I do. Most of you do anyway. So this one is 4 times x squared, all divided by 2. 4 divided by 2 is 2. This one I can't reduce, so that one I am okay. And there is our answer. Okay, the last one. As I mentioned in class, there is no product rule. So if you've got two functions being multiplied together, you got to multiply them out, because there is no such thing as a product rule for integration, nor a quotient rule. So, or at least not that I'm aware of. Maybe in higher levels of mathematics there's a way of figuring that out, but at our level that we're doing, that I teach, we do not have one. So we're going to multiply this out. So I'm going to distribute this. So I'm going to rewrite. So rewrite as a sum. Rewrite as a sum. Okay, distribute it. So I can rewrite this as x times x is x squared. X times negative 4, that's minus 4x. 1 times x plus 1x. 1 times negative 4 dx. I can combine my like terms. So I'm going to have x squared minus 3x minus 4 dx. Now, just like the previous problem, I can now separate this into 3 integrals. So I'm going to have integral of x squared minus the integral of 3x minus the integral of 4, and I forgot to write my dx's. Let me move this over. Dx. Forgot to write my dx. Yes. Okay, like that. And then I'm going to go ahead and integrate this. So I'm going to get x to the 2 plus 1 over 2 plus 1. I'm going to bring out my 3. And then I have times x to the invisible exponent is 1, so 1 plus 1 over 1 plus 1, minus, I just have a constant there, so I just slap an x next to it, because there was no x. All right, now we can simplify these. And, oops, don't forget my plus c. Simplify these, I get x cubed over 3 minus 3x squared over 2 minus 4x plus c. Fine, let's see, did I do everything right? Yep, there it is, final answer. I just noticed looking back that really to make this look a little bit better, I should have put a plus c right here. But I did put it on my final answer, so here's my final answer. Here's my final answer. Okay, and again, I could have written this, what is it? I could have written this one as 1/3 x cubed minus 3/2 x squared minus 4x plus c. So you can write it like that. Let's go ahead and just write it the other way for those of you who prefer. You could have written it as 1/3 x cubed minus 3/2 x squared minus 4x plus c. Okay, either way is perfectly acceptable. Okay, so next week we will be looking at what does this symbol mean? It means it's a sum. Why the heck does this mean it's a sum? So we'll be talking about that next week. Right now we're just thinking about it as an antiderivative going backwards. In other words, you know the derivative, what was the original function? So that's how we're thinking about it right now, and next week we'll figure out why do they call it a sum. See ya. Have a good weekend.